Hello and welcome to today's lesson on ionization and comparing the ionizing powers of different types of radiation. Our plan is as follows. First, we'll learn what ionization is, and from this, we'll explore what is meant by ionizing power. Finally, we will compare the ionizing powers of alpha, beta, and gamma radiation. So far, you have become familiar with the different types of radiation, alpha, beta, neutron, and gamma radiation, and their associated nuclear equations. Building on this foundation, we can now delve deeper into the specifics of ionization and the varying ionizing powers of different radiation types. This will enhance our understanding of the principles governing radiation and its effects on matter. Let's get started. Ionization refers to the process where one or more electrons are removed from an atom or molecule. This removal creates charged particles known as ions. When high-energy radiation, such as alpha, beta, or gamma radiation, interacts with atoms or molecules, it can transfer enough energy to dislodge electrons, thereby ionizing the atoms. Ionizing power indicates how effectively radiation can cause ionization. Let's examine the ionizing power of alpha particles, beta particles, and gamma rays. Alpha particles are relatively large, consisting of 2 protons and 2 neutrons, giving them a double positive charge of +2. Due to their size and charge, alpha particles are highly effective at interacting with surrounding atoms. As they pass through material, they collide frequently with nearby atoms. Their positive charge attracts the atom's electrons, knocking these electrons out of their orbits and causing significant ionization. This high frequency of collisions results in alpha particles having the highest ionizing power among the 3 types of radiation. Beta particles are much smaller than alpha particles and carry a single negative charge, similar to an electron. Although they can still ionize atoms by knocking off electrons, their smaller size and lower charge mean they cause fewer collisions compared to alpha particles. Therefore, while beta particles do have ionizing power, it is lower than that of alpha particles. Gamma rays are very different from alpha and beta particles. They are electromagnetic waves with no mass or charge, which means that they interact less directly with atoms. Gamma rays can still cause ionization by transferring energy to electrons within atoms, but because they lack mass and charge, their ionizing power is significantly lower than that of alpha and beta particles. To summarize, the differences in ionizing power among alpha particles, beta particles, and gamma rays arise from their size and charge. Alpha particles, having the largest mass and strongest charge, have the highest ionizing power, followed by the smaller and less charged beta particles, and finally followed by the massless and chargeless gamma rays, which have the lowest ionizing power. To visually demonstrate the ionizing effect of radiation, we can use a gold leaf electroscope. The electroscope consists of a metal rod connected to a thin gold leaf inside a sealed container. When the metal rod is given a positive or negative charge, the gold leaf, being connected to the rod, also becomes charged and repels away from the rod, causing it to rise due to electrostatic repulsion. Suppose the electroscope is first charged positively and the leaf is now standing apart from the stem. Now, when a source of alpha radiation, like radium, is brought close to the charged electroscope, something interesting happens. The alpha particles emitted by the radium have a strong ionizing effect. They can knock electrons out of the air molecules around the electroscope. The electrons knocked free by the alpha particles are attracted to the positively charged electroscope, neutralizing the charge. As a result, the gold leaf will gradually fall back down as the charge on the rod decreases. It's essential to understand that it's not the alpha particles themselves directly discharging the electroscope, but rather the ions they produce in the surrounding air. The ionization process neutralizes the electroscope's charge, causing the observable collapse of the gold leaf. This process visually demonstrates the ionizing power of radiation. The more ionizing the radiation, the more effectively it can neutralize the charge on the electroscope, causing the gold leaf to drop faster. For instance, alpha particles with their high ionizing power will cause a noticeable drop in the gold leaf's position much quicker than beta particles or gamma rays. In summary, the gold leaf electroscope is a valuable tool in illustrating ionization. It shows how radiation can create ions that neutralize the charge on the electroscope, resulting in the visible movement of the gold leaf. In today's lesson, we delved into the concept of ionization, learning that it involves the removal of electrons from an atom or molecule, resulting in the formation of charged particles called ions. We then examined and compared the ionizing powers of different types of radiation, concluding that alpha particles are the most effective at ionizing atoms, followed by beta particles, with gamma rays having the least ionizing power. Understanding these differences is crucial in various applications, from medical treatments to nuclear safety.